Hello everyone, welcome to my channel Chem Insider. In the previous videos, we discussed about various nomenclatures of hydrocarbon, those which have branched chain, those which have functional group, and also about the benzene ring compounds and the derivatives. Now in this particular video, we'll just discuss about several examples of how to name Iupac nomenclature for certain organic compounds and how to write structure for organic compound using the Iupac nomenclature. We need to try both. By observing the structure, we need to write the Iupac name, and by using the Iupac name, we need to draw the structures also. Okay, we'll solve certain few examples, each of one of the particular cases. So now, the first one example here given is a bond line diagram for a hydrocarbon having branch in it. So if you observe carefully, we had discussed about the branched chain hydrocarbon representation, where terminal position gives a methyl group and the non-terminal position is nothing but a CH2 group. If a non-terminal position has one more bond present in it, that means there is a substitution. Okay. So now, if you consider for this particular hydrocarbon, what you have to do is, this is a branched chain hydrocarbon. So we have 6 rules, right? First one is, we need to calculate the highest number of carbons present in a parent skeleton. So highest carbon present is 1, 2, 3, 4, 5, 6, 7. So there are 7 carbon atoms in the highest parent chain. So 7 carbon atoms, root word is hept. Since there is no presence of any double bond indication, therefore this is clearly heptane. Now for the substitution, you can consider this carbon atom and this carbon atom as the substitution. Once you consider the substitution, next we have to do is the second rule. You need to remember the substitution and number the substitution in such a way that the substituted carbon atom gets the lowest number possible. So now for numbering, if you start from left, 1, 2, 3, 4, 5, 6, 7. If you start from right, 1, 2, 3, 4, 5, 6. So clearly, from the left hand side is the better option. Now, since we have 2 methyl groups, that is substitution of identical groups at different positions. So what you have to do is, we need to number the positions such as 2, 5 first, then write a hyphen. Since both the groups are similar, you need to write the prefix di. The group is methyl. The compound is 2,5-dimethyl heptane. The compound name is 2,5-dimethyl heptane. Now, second example. So this is an example where you have 2 functional groups. One which is always a suffix, one which is always a prefix. Now for the total number of carbon atoms present here. So this is a chlorine atom, we cannot consider as a carbon. So number of carbon is 1, 2, 3. So we have 3 carbon atoms and numbering should be started from the preferential order. If you have 2 or more functional groups, we need to consider first functional group as a primary or principal functional group and the other as the subordinate. So the functional group which is a principal over in these 2 conditions is CHO group, aldehyde group. So this is the first carbon, second carbon and third carbon. So 3 carbon group is right? Propane, if you write it as propane. Since we have a CHO group at the terminal position, that is an aldehyde. An aldehyde should always have a suffix, that is Al, right? Propanol. And the Cl group is present at the third position, given by the symbol 3-chloro. 3-chloropropanol. The name for the compound is 3-chloropropanol. Now, in this particular condition, we have a benzene ring and a side chain hydrocarbon. Remember, when we discussed about the Iupac nomenclature of benzene and its compounds, what we said was, whenever you come across a substitution where benzene ring has a particular side chain present, what you have to do is, we need to consider benzene ring as our substituent. Therefore, now the benzene ring is considered as a substituent which is given a prefix phenyl. this is group of phenyl, and the number of carbon atoms is 1, 2, 3, 4. So then we have one more substitution at this position. Okay. So now this is a 4 carbon group named as butane. This is a 4 carbon group named as butane. We have two substitutions, one at the third position and one at the first position. So while naming, we have phenyl group and a methyl group. Phenyl group is at the first position, methyl group is at the third position. Now, whenever you have two functional groups, two different functional groups or substitution in a branched chain, we need to name them according to the alphabetical order. So out of phenyl and methyl, methyl comes first. Therefore, the name of this compound will be 3-methyl 1-phenyl butane. 3-methyl 1-phenyl butane. So this is the name of this particular compound. Now for this example, so this is a cyclic hydrocarbon. So cyclic hydrocarbon having a double bond and a OH group. So whenever you have two functional groups, what you have to do is we need to name them, number them in such a way that the preferred hydrocarbon or a functional group should get the lowest number. So start from this side, 1. Okay, so this should be the first carbon. Now for the double bond, you can consider this carbon atom or this carbon atom. If you come across in this way, we have 1, 2, 3, 4. If you come in that direction, 2, 3. So now best suited double bond is at the third position. So name of this particular compound is cyclohexane. Cyclohexane. First the compound name is cyclohexane. Since we have OH group and double bond, OH group indicates a suffix hydroxy, and further we have a double bond which is also indicate a suffix itself. Therefore, this compound has cyclohexane and a double bond at third position, OH group at the first position. Therefore, the name of this compound will be cyclohexane 3-in-1-all. 3-in-1-all. So this is the name of this compound, cyclohexane 3-in-1-all. Okay, alcohol is considered as the principal functional group, therefore it is a suffix. And further, if you consider this as a subordinate functional group also, alkenes or alkanes always come under the suffix itself. Therefore this is cyclohexane 3-in-1-all. Now for this particular compound, here we have CH3 group, Cl group and OMe group. Now out of these three groups, we have a benzene ring with OMe, a common name known as anisole. So whenever you have a benzene ring with the OMe group, that is called an anisole compound. So this is the parent compound name is anisole. And these two are nothing but the substitution. So if you start from this carbon, 1, 2, 3, 4. The name of the compound will be 3-chloro 4-methyl 3-chloro 4-methyl anisole. So that is about the naming of certain organic compound according to the Iupac nomenclature. So we have discussed all type of examples, one which has just branched chain, one which has substitution of functional group, one which has a benzene ring and a hydrocarbon, cyclohexane group and a benzene group. Next, we will try to write the structure of a particular hydrocarbon using the Iupac names. Now, let us write the structures for compounds with having particular Iupac nomenclature. So first compound is, we need to write the structure for the Iupac nomenclature given as 2-chloro 3-methyl octane. So first, since they have given octane, let us write an 8-membered hydrocarbon. So I am just going to write the bond line structure, that is more than enough. Okay. For the first one, A, 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8-member hydrocarbon. 1, 2, 3, 4, 5, 6, 7, 8. Now, whenever you write an structure for Iupac nomenclature of a hydrocarbon undergoing branches, always prefer the numbering from the left hand, so from this side. Okay, start the numbering from this side. So we have a second place substitution and a third place substitution. So this is the first carbon, second carbon, third, fourth, fifth, sixth, seventh, and the eighth. Okay, and always prefer the substitution which will be directed in this direction, but not in this. Don't write the substitution in this direction. Write the substitution in this particular direction. So second position, and this is the third position, substitution. In the second position, we have a chloro group, 2 chloro. So that means we are writing a Cl. In the third position, we have methyl. So you can just write down that itself. Okay. So this will be the structure for 2 chloro 3 methyl octane. Now for the second compound, they have given us 4 hydroxy 2 chloro pentanoic acid. 4 hydroxy 2 chloro pentanoic acid. So it should be 2 chloro 4 hydroxy. 2 chloro 4 hydroxy, because alphabetical order has to be represented. 2 chloro 4 hydroxy pentanoic acid. Since they have given pentane, that means 5 membered carbon atoms. 1, 2, 3, 4, 5. Okay, so this is a 5 membered group. 1, 2, 3, 4, 5. So pentanoic acid always has a COOH group at the first position. So double bond O, OH. You can either write in this direction, in this type, or you can also write this is a COOH. Okay, both are same, doesn't matter. So we have 1, 2, 3, 4, 5. 5 carbon atoms. Next, they have given us second position has a chloro group. So this is the first, second, third, fourth, and fifth. So the second position has a Cl group, and the fourth position has a OH group. So this is a structure for 2 chloro 4 hydroxy pentanoic acid. Next, for the third compound, so they have given us 2,4 dibromo 3 methyl aniline. First, write down the structure for aniline. Aniline is a benzene derivative which has NH2 group directly attached to the benzene ring. So this is a benzene ring, and if an NH2 group is directly attached to it, we call it as aniline. And always consider that particular carbon as the first carbon. Now the substitution is presented 2, 4, and third position. So we have a second position substitution, third position substitution, and a fourth position substitution. Okay. So the second position we have a bromo group Br. Same applies at the fourth position. And in the third position we have methyl group CH3. So this is the structure for 2,4 dibromo 3 methyl aniline. Next, we'll come for the fourth one. They have given us 5 chloro cyclohepta 3 ine. So they have given us YNE group. First, they have given us cyclohepta. That means we have 7 membered cyclic ring. So 1, 2, 3, 4, 5, 6, 7. Always first write down the number of dots so that indicates the number of carbon atoms, so that you could clearly get a complete image. Okay, so now this is a 7 membered cyclic hydrocarbon. Now what you have to do is we need to consider numbering in such a way that we give a least number as possible. Okay, so now in this particular compound, what we can do is we'll put one more functional group, 1 amino. Okay, 1 amino. So the first position we have an amino group. So let us write 1 amino. So let this be the amino group NH2. So this is the first position, and at the third position we have a triple bond. So 1, 2, 3. So this is the third position. We have a triple bond over there. 1, 2, and 3. So clearly we have a triple bond at the third position, and at the fifth position we have a chloro group, 3, 4, 5. So we have Cl over here. So this is 1 amino, 5 chloro, cyclohepta, 3 ine. So this is the structure for the particular compound of Iupac nomenclature. Okay, so these are certain examples of how to write the structure of an hydrocarbon using its Iupac nomenclature. In the next video, we'll discuss about isomerism which we observe in hydrocarbons. I hope you have understood how to write the structure from an Iupac name and how to write the Iupac name for different structures. Okay, so if you have understood these concepts, please do subscribe to my channel and share this video among your friends. Thank you for watching.